How does the angle the coin make at the time it is caught determine what the outcome of the toss is? Well, let's take a look. So recall we have a formula that the angle at termination is twice omega v over j. Let's look at all possibilities for the angle. If the angle was 0, then heads is pointing upwards, and so I would say I get a heads. As the angle increases from 0 to 90 degrees, you'll notice head is still pointing upwards, and therefore for all angles up till 90 degrees, you will get a head. Now, the moment the coin crosses the 90-degree angle with the horizontal, now you'll notice head points downwards, and it is tails that is pointing up. And tails, it remains from 90 degrees all the way up to 270 degrees. Beyond 270 degrees, the coin becomes heads again. And so we get 180-degree swings. For every 180 degrees, you get heads. The next 180 degrees, you get tails, then heads again, then tails, and then heads, and we get this very simple description. Writing it in terms of radians, from 0 to pi over 2 radians, the coin will end up showing heads. From pi over 2 to 3 pi over 2 radians, the coin will show tails. From 3 pi over 2 to 5 pi over 2 radians, the coin again shows heads, then tails, then heads, and so forth. So now we have an understanding of what the outcome of the coin toss would be, depending upon where theta of tau is in this range of possibilities. The critical points, of course, are right at angles 90 degrees, 270 degrees, and so forth. Right at angles pi over 2, 3 pi over 2, 5 pi over 2, and in general, any odd multiple of pi over 2. And so, it behooves us to consider what the equations say right at those branch points where we're trembling on the edge between a head and a tail. So we'll want to solve the equations where theta of tau is exactly an odd multiple of pi over 2. Now remember, theta of tau is twice omega v over j. And therefore, in terms of the parameters that initiate the experiment, the translational velocity v and the angular velocity omega, we are looking at the equations omega v is equal to pi times g over 4, omega v is equal to 3 times pi g over 4, 5 times pi g over 4, and so on and so forth. Of course, our question here is, how do these initial parameters, the specification of v and omega, determine the outcome? Well, let's take a look at the first of these equations. Theta of tau is pi over 2, or equivalently, omega times v is pi times g over 4. If we think of omega and v as free parameters, free variables, then what you've got describes, as you'll recall from middle school, the equation of a hyperbola. And so you've got a line here, a hyperbolic line, corresponding to all possibilities for the velocity and the angular velocity, v and omega, which give rise to exactly 90 degrees in the terminal coin angle. And you notice we've got this nice hyperbolic line. Now, what happens if you have a value anywhere less than 90 degrees? If the coin toss results in an angle less than 90 degrees at termination, then you are going to be somewhere below that hyperbolic line. So all choices of v and omega, which lie beneath the hyperbolic line and are captured by the axes, that entire region will result in a head. Now a pretty picture is emerging. Right? Of course, the moment you cross 90 degrees, you start getting a tail. But then there's a next branch point at 3 times pi over 2, or 270 degrees. So it now becomes clear that what we should plot is all the lines at which the terminal angle is an odd multiple of pi over 2. And so here's what it looks like. So I've plotted for you the hyperbolic line, those values of v and omega for which the terminal angle is pi over 2, then 3 pi over 2, 5 pi over 2, and so forth. And we get this family of hyperbolic lines. Now, what are the results that emerge from this experiment? Well, let's start by imagining a coin toss with a certain speed v and a certain angular velocity omega, which is such that omega times v is beneath the first hyperbolic line. Now, in this case, the coin is going to show you heads, and therefore, for everything in that shaded region between the first hyperbolic line and your axes, you're going to get a head. Now, what if your speed and angular velocity are such that you lie above that first hyperbolic line and just below the next hyperbolic line where the angle is 3 pi over 2? At this point, you get a tail. In fact, all combinations of speed and angular velocity which lie in that second pale band are going to give you a tail. The next band, these combinations of speed and velocity and angular velocity will give you a head. And likewise, the next one will give you a tail, and so on and so forth. And therefore, the red shaded regions in the curve correspond to combinations of velocity and angular velocity, which will give rise to a head when you catch the coin, and the unshaded regions in your picture will give you points which result in tails.